Good morning, everyone. I come again. Previously, we settled the question for A and B, and now we will solve the problem of part C. All right. So if we look at the question itself, it is requiring us to calculate the starting torque. Because this motor is in inductance motor, right? Yeah. As I said previously, the basic physical law for the inductance motor is a Faraday's law, right? Faraday's law, which is EMF equals minus N d phi BD divided by dt. Okay, which means there should be a speed difference which can generate the d phi b divided by dt. All right? Yeah, that's a theoretical basis. So for our inductance motor, the angular speed of stator is larger than the angular speed of rotor. So the speed difference between these two parts will generate the electromotive force, which is with the unit of volts. All right. So this difference will generate a starting torque. So this scenario is quite different with a synchronous motor. Because for synchronous motor, the angular speed of stator and rotor are the same. So it requires an external starting torque. All right. Let's focus on this question. At the very beginning of the inductance motor, the rotor will be static, not moving. So the angular speed for the rotor will be 0. As a result, because slip number equals ns subtract nr divided by ns, which should be ns divided by ns, which is 1. So the directly result for this value of slip number is the R2 divided by S. Previously, it is 7.1 ohm, but presently it is just the R2 itself, which is 0.355 ohms. All right, sooner we just repeat the previous sequence as shown in the part A, which is we don't forget this equivalent circuit. Z1, Z2, 25J, which is JXM. Okay, and we calculate the parallel resistance. Sorry, the parallel impedance again, which is 25J plus 0.355 plus 0.9J and 25J multiply 0.355 plus 0.9J. Okay, this is the JXM, this is Z2. And we can calculate the new value for the parallel total impedance, which after we get the result, we can get the new entire impedance for the whole circuit, which is the total equals the parallel plus Z1. And the final result is 0.45 plus 0.9G plus Z parallel, which is 1.94, 66.23 ohm. And just mention it, don't forget the method to calculate this thing. which is, for example, z equals a plus bj, and this is c plus dj. Also got its number. So a plus bj multiply a subtract bj, c plus dj times a minus bj. So we just simplify this equation, we can get the expression for a complex number. All right. Okay, now we get the new total impedance for the whole circuit, and consequently we can get the new total current, which is I1 for the total circuit, which is V base divided by Z total, which is like this, and for this value. Okay, so finally we can get the new value of our entire current in the circuit, which is 119.23 minus 23 degree ampere. All right, so as shown in the part A, after we get the value of I1, we will get the value of Vp for the parallel or for the Z2, okay? This value equals the total value of the phase voltage subtract the voltage of Z1, which is Vp subtract I1 times Z1, okay? The Vp is 400 divided by square root 3, subtract 1 point this number, okay? This 0.355 plus 0.9 G. So the process of calculation is quite complex. We don't do it right now, but you can finish the calculation in your spare time. I just write the final answer here, which is 111.3 volts. And we can get, this is the absolute number. Yeah, we don't need the angle here. And furtherly, we can get the, we can get the new value of I2, which is the current that runs through the Z2, okay, which is Vp parallel divided by Z2. Okay, this is 111.3 divided by this one, 0.355 square plus 0.9 square. The final answer is 115.1 ampere. All right. Okay, we are required to get the starting torque, and we know P equals tau times I. All right. So what will the current, this current result? It results the air gap, air gap power. Yeah. So this power is air gap power. This is our starting torque. This is our I2. Okay. So we can get our target. The starting torque equals P air power divided by I2, which, oh, sorry, I think I made a mistake. It's not I2. Sorry. It's about the omega, yeah, synchronous omega, which is the angular frequency for the stator. Yes, forgive me. I just made a mistake. So it can be got for the final result for the value of starting torque, which is P air gap divided by omega synchronous. All right. Okay. So the value of air gap, new air gap, is 3, which means the 3 phase. times I2 square times our 0.355, which is R2. And because our frequency is still 60 Hertz, so the omega s or omega synchronous will be the same, 188.5. Okay, so we just input all the value inside. We can get the final result, which is 74.85 Newton meters. Thank you. That's all for this question. Have a good day.